Let's get started going over the Unit 2 review. It may seem like knowing the types of bonds is memorization, but it's really not if you think about examples. Metallic bonding, for instance. Let's think of copper as we go through this, that a penny is made out of. Ionic, let's think of table salt, NaCl. Network covalent, an example of that is sand, SiO2, that's sand. Molecular covalent, these are often smelly things, okay, so gases, and not that all gases have a smell, but some of them do. Sugar is an example. It is something that melts really easily. Okay, so that actually gives away number one. Something that's a soft, solid, low melting point, distinct odor, that matches up mostly with molecular covalent. Number two, which of these easily dissolves in water? Well, sugar does, but it has a low melting point, and this one says it also has a high melting point. So this must be ionic. I always say you don't put salt on your French fries and see it turn into a liquid. Okay? Number three, it's a gas. So automatically we can think of molecular covalent. Molecular covalent. Cobalt is one of the transition metals. So that would be like copper. So this would have metallic bonding. Plain old silicon, that's a solid. This is a tough one. It's a non-metal, okay, and it is most similar to sand. It's network covalent. It's a hard solid. If you've forgotten how to do electron configurations, go back to the Unit 1.3 section and watch a video. Okay? It says we can give the shorthand, so let's do that for lithium. Helium is the last noble gas, and then it's 2s1. Lithium is to the left of the zigzag, so it's a metal. It's in group 1a, so it has one valence electron. It would like to lose one to be like helium. If you lose an electron, now you've got more protons than electrons, so you've got a positive 1 charge. The last noble gas before chlorine is neon, and then it's 3s2, 3p5. It's to the right of the zigzag, so it's a nonmetal. It's in group 7a, so 7 valence electrons. It would like to gain 1 to be like argon. And so the charge that it forms, once that it's gained 1, negative, it's going to have an extra electron over protons. How do I get this clock to go away? All right. Letter C, fill in the table. This is just a big old crisscross fest. So sulfur's a -2, fluorine's a -1, oxygen's a -2, phosphorus is a -3, sodium's a +1. Okay, those are going to be on the orange post-its above the groups on the periodic table. Okay, so if it helps you to go off to the side to show the crisscross, you can do that. But like sodium and fluorine, that's just +1 and -1. So you can just slap them together. Sodium and oxygen though, sodium's got a +1, oxygen's a -2, so you have to crisscross. So it comes out to be Na2O. Same here with phosphorus. Na's got a +1, phosphorus has got a -3. Crisscross, cross the 3 over, cross the 1 over, but you don't need to write the 1. Okay, this next one's interesting. Pb's got a +4, sulfur's got a -2, so when you crisscross, it's Pb2S4. That can be simplified. Divide both numbers by 2, and it becomes PbS2. Okay, so then following the pattern, it should be PbF4. It should be PbO2 again, very similar to the PbS2. And it should be for this last one, Pb3P4. Letter D, identify these as a lattice or a molecule. Well, lattice structures come from ionic substances, which have a metal and a nonmetal. Molecules come from covalent substances, all nonmetals. So calcium's to the left of the zigzag, SO4 is to the right, all of those elements. So this would form a lattice structure because it has ionic bonding. Hydrogen's a nonmetal, chlorine's a nonmetal. So this would form a molecule. And the last one, metal and nonmetals, this would form a lattice. Naming. Number 1, this would be lithium chloride, not chlorine because you changed the ending to "ide." Let's go down. This has a transition metal. That means you should automatically write iron, leave a blank, and then chloride. But what goes in there? Well, this iron is canceling out 3 chlorines. Chlorine always has a -1 charge. So altogether, it's canceling out a -3. So this iron must have a +3 charge. So we put a Roman numeral 3 there. Number 3 is straightforward, sodium bromide. Oops, sodium bromide. I can't write. And number 4, nickel is a transition metal. So automatically, so you don't forget, nickel, leave some space, phosphide. Phosphide always has a -3 charge. So what cancels out a -3? A +3. So that would be nickel 3 phosphide. Letter F, you're supposed to crisscross. This is a weird one. Lead's not a transition metal, but it does have multiple charges. So lead 2 bromide, let's crisscross. It becomes PbBr2. Silver iodide. Silver always has a +1 charge. Iodine's got a -1, so this one just becomes AgI. Calcium's got a +2. Bromine's got a -1, so this is CaBr2. Tin, this is a special element because tin can have multiple charges even though it's not a transition metal, so kind of confusing. SN2O4, we can simplify that, divide both numbers by 2, it becomes SnO2. More practice with naming. These have polyatomic ions. You still need to have those 6 polyatomic ions memorized. So first one here, we've got calcium carbonate. Next one, aluminum nitrate. These are not transition metals, so we do not need Roman numerals. But this one does have a transition metal, and it's got a polyatomic ion, so we got to leave space. Nickel something hydroxide. How do we figure out what goes in there? Well, this nickel is canceling out 2 things, each which has a -1 charge. So it's canceling out a -2. That means this nickel must have a +2 charge. Number 5 is ammonium nitride. H, writing with polyatomic ions. Ammonium chloride, NH4Cl, let's check the charges, +1, -1, boom, we could slam them together. Strontium, +2 charge, hydroxide, -1, so we need to crisscross, which means we need parentheses, because anytime you have more than one polyatomic ion, you need parentheses. Number 3, copper's got a +1, sulfate's got a -2, this becomes Cu2SO4. Cobalt has a +2 charge, nitrate, NO3 with a -1, so this needs parentheses because it'll be CONO3 2. Here are those polyatomic ions again. Carbonate is CO3 with a -2. Hydroxide is OH with a -1. Nitrate NO3 with a -1. Phosphate PO4 with a -3. Sulfate SO4 with a -2. And ammonium's the only positive one. NH4 with a positive 1 charge. Letter J, pick 2 types of bonding. Explain the role of electrons in each type of bond. What are the electrons doing? How are they involved? Let's use ionic bonds first. The role of the electrons is the metal gives up electrons to the nonmetal. So the metal ends up having a positive charge, the nonmetal ends up having a negative charge, and the 2 ions are attracted together. A lot of times you'll see this labeled as there's a transfer of electrons. Okay? Covalent bonds are between nonmetals. So nonmetals share electrons in this type of bond. Finally, just to be thorough, I'm going to add it in here. Metallic bonding is all metals basically share their electrons. They create a sea of electrons. I always say that this one's like a potluck. They all bring their electrons and share them together. Letter K. What group of elements would form a one-on-one relationship with nitrogen? Well, nitrogen would like to gain 3 electrons and form a -3 charge. So this question's really asking, what group would like to give up 3 electrons? And the answer is group 3A. They would all like to lose 3 and form a +3 charge, which would exactly cancel out nitrogen. Letter L, draw a Bohr diagram of magnesium and chloride. Show where and how many electrons will be gained or lost by each, and explain why it forms MgCl2. Okay? Well, magnesium's got 12 protons in its core. It's got 2 electrons, 8 electrons. In its outer shell, it's got 2 electrons. So it wants to get rid of those 2. Chlorine, on the other hand, 17 protons. It's got 2 electrons, 8 electrons, and it's so close to having the great 8, it's got 7 electrons in its outer shell. I'm going to redraw magnesium's electrons in its outer shell as 2 dots. So magnesium can give one of these to a chlorine atom, then it'll have the great 8, and since the electrons will now be winning by 1, this chlorine will have a -1 charge. Well, this electron's got to go somewhere else. It's got to go to a second chlorine. I'm just going to draw the outer shell on this one. So you need 2 chlorines to satisfy this magnesium. Once magnesium is down 2 electrons, it's going to have a +2 charge. So magnesium 2+ with each of the 2 chlorines, notice how the charges are going to cancel out and become 0. So the final compound is indeed MgCl2. Hopefully that helped you, and good luck studying.